Hello and welcome to another Java tutorial. In this tutorial, I'm going to continue our discussion on Java native interface and look at a very important topic on how to use Maven when we are basically working with Java native interface. So in Eclipse IDE or all of the other Java IDEs, they all have support for Maven. If you don't know what Maven is a Java build tool. So it's basically a build tool for Java. And then it has concepts such as goals and plugins. So you can have a compiler plugin that has a goal such as compile, which compiles all the Java files and creates the class file, .class files. And then the compiler plugin can also have a goal called test, which means it compiles the Java files, creates the classes. It also compiles all the Java files that you specified as test cases, and then compiles them and then runs the tests, which typically works with JUnit. And then there is another target, which is package, which packages the Java project into a jar. All right. And then Maven always prefers convention over configuration. What this means is that Maven asks the developers to adhere to a standard folder structure. This is a folder structure that is by default Maven wants you to use. Source main Java, and you put all your Java source files in this source folder, source main Java. Source main resources, we add all of our resources in this folder, including the dynamic library that we're going to have for the Maven project. And then source test Java, obviously the name is very clear. You put all your Java files that contain test cases for your Java project. And source test resources, all the resource files that you need to execute those test cases. So source main Java, source main resources, source test Java, source test resources. So the main difference here between a Maven project and a simple Eclipse Java project is that we have this folder structure, and the main point here is that when we have this resources folder, we should put our dynamic libraries that we generate after compiling our C++ code inside these resources, and it automatically copies that into the top root, basically the root of the jar file that it creates. All right. So if you change some of the properties of the Maven project, for example, by default the Maven compiler uses Java 5. So if you want to change it, you have to use one of the properties of the Maven. So Maven compiler.source, which uses JDK 8. You set it to 1.8. And then the target platform, which is we want to also be at the JDK 8 level, right, when we compile the Java files and create class files. And once you set these properties, you have to update your Maven project. So you right click on your Maven project, go to the Maven option and update project, select the project that you want to update, and then update it. All right. So Maven, again, if you're not that much familiar with Maven uses something called POM, P-O-M, which is an acronym for Project Object Model. It's an XML file which has some tags, XML tags that specify, for example, the dependencies, the profile, the plugins, the Maven plugins that were used, and all this kind of stuff. And it gives you a whole deal of configurability. So the developer has a lot of options in terms of the way he or she wants to build the Maven project. All right. But for us, I'm not going to go into the details of the Maven and how it works. But what I want to discuss here is that how to add a dynamic library, basically how to create the Java files. You run the Java H tool, the external tool that we use to generate the header files, and create the header file, and then create a dynamic library, and then how to put it inside this resources folder, and then how to use the package goal of the Maven, and how to correctly include that dynamic library into the jar file that the Maven creates. All right. so that we can basically distribute that jar file, and then others can readily use the jar, which includes also the native library. Alright, so our goal is to correctly package dynamic library into the Maven build. So obviously the first step is to create a Maven project and then create the Java files, some of them that have native methods, right? And then next we need to build the project with Maven. Note that Eclipse is not building the project for us. We are building the project with Maven, and obviously the first step is to compile. So we have to use the compiler plugin and use the compile goal. So the goal is going to be compile, and we're using the compiler project plugin. So build the Maven project with Maven build for the compile phase. And then what happens here is that Maven creates a folder called target, and inside that creates another folder called classes, and puts all the packages and all the class files inside that classes folder. So that classes, so in a regular Eclipse project, we have the bin folder, and all the compiled class files are put inside that bin folder, right? However, with Maven, it creates a folder inside the target folder, which is called classes, and puts all the packages and the compiled class files inside this classes folder, right? So the binary, or the root of the binary or class hierarchy, are inside the project name /target/classes path. So this is important because this is different from what Eclipse normally does for Java projects. Eclipse puts them in the project name /bin. And the reason this is important to know is because when we set up the Java Edge tool, the external tool that creates the header files from the class files, we need to specify the root of the class files. And for a regular Java project, it's project name /bin. For a Maven project, it's going to be project name /target folder /classes, because Maven by default puts the compiled classes inside this classes folder. All right. So have this in mind. This is the most important point here when we're working with Maven and JNI. So after we build the project and compile it and create this classes folder, set up the Java Edge external tool or Java C-Edge, both work fine. Set up the Java Edge external tool to point to the classes folder. All right. So instead of pointing to a bin folder that we typically used with regular Java projects, we're going to point the Java Edge tool to the classes folder. All right, this is the main difference from Java Edge when using a regular Java project in Eclipse, because when using a regular Java project, we point the Java Edge to the bin folder. Here with Maven, we point it to the classes folder, so target/classes. And then we run the Java Edge tool, and then we create the header file, we create our C++ project, we compile it, we create a dynamic library, and copy and paste the dynamic library into this resources folder. This basically, when the Maven creates the jar file, it puts this any file inside this resources folder is going to be at the top of the jar file, or at the root of the jar file, right? And then we said that if we put a dynamic library inside the jar, the JVM cannot load it, because the dynamic library should be inside a folder, not a zip file, because jar files are basically a zip file. In order to basically be able to actually load the dynamic library, we use this native utils class, which is a simple Java file in this GitHub repository, github.com Adam Heinrich /native utils. I always include this in my it's a simple Java file, and you can download it, copy and paste it to your Java project. And then after you add your dynamic library to the root of source main resources, right, instead of using system.load library, we use native utils.load from jar. And then when we do that, load from jar, we have to specify where the dynamic library is with respect to the root of the jar file. And if we copy our dynamic library to the src/main/resources, and then the dynamic library is going to be at the root of the jar file, which is specified by this /. And then when we use this load from jar from native utils, it internally calls the system.load instead of system.load library. So it calls the system.load, And when we use system.load, we have to specify the full name of the dynamic library. So we shouldn't drop the lib from the beginning or the extension from the end. So a slash tells the native utils where dynamic library is within the root of the jar file, and then what is the full name of the dynamic library. Lib, and these stars mean whatever the name of the dynamic library is, and then also the extension .dylib, right? You must specify full name of dynamic library. So the next slide here, we just quickly have a look at how to set up the Java Edge tool, the external tool for the Maven project. So I have created this Java Edge underscore Maven, and it is pointing to my Java Edge tool from JDK 8. Even if you're using JDK 14 or any JDK after JDK 8, you can still download JDK 8 and you point this external to the Java Edge inside the JDK 8. So there is no problem with that. It's fully compatible with the later versions of JDK, so you can use it. I always recommend to use Java Edge instead of Java C-Edge, but again, that's a choice that you can have. And then the important part is this working directory, right? So you create your Java Edge configuration here, point it to Java Edge, and then working directory. So you have to point Java Edge to the root folder that contains all the class files. And we said that for a regular Eclipse project, it's workspace slash project name slash bin, right? However, for Maven projects, it's workspace slash project name slash target slash classes, because when you run the compiler plugin and compile all the class Java files, it creates this classes folder and puts all the compiled Java files inside these classes folders, right? So this classes folder is the root of the binary, right? Binary, Java binaries, all the class files. So this is the main difference. And then for the arguments, obviously we want to create a C++ project and ask Java Edge to put the header files inside a header folder that we create in the C++ project. So we use this -d directory and tell the Java Edge where to actually put the header files. Here I'm saying that workspace slash some C++ project name slash the header folder inside this project. And then we have to use the -JNI with Java Edge, and then Java type name, which is the fully qualified class name, right? From the root of the binary folder, which in this case is the classes, right? So this is how we set up the Java Edge tool, the external tool for a Maven project, all right? So the main difference is in the working directory, we have to point it to the /target/classes, all right? So let's head to Eclipse and try to quickly look at creating a Maven project and then a C++ project and use JNI. So in Eclipse, I'm going to create a new working set here, Java working set. Let's call it or demo underscore Maven, and I'm going to select it. Right now it's empty, so I'm going to create a new Java project. I'm going to call it Maven underscore native. Okay, I'm going to create actually a Maven project. So Maven project. Let's create a simple project, and let's call this org.maven.demo and artifact Maven underscore native, and we want to package as jar. All right, everything looks good, and let's go and add it to our working set. So edit active working set and Maven native. Okay, right now there is a warning on the Maven project in Eclipse, and that's because it's using an older version of JDK or JRE 1.5. I want to switch it to 1.8. So what I do, I open this pom XML file, and in the properties I'm going to say maven.compiler.source 1.8 and maven.compiler-plugin.target 1.8. all right, and then I'm going to right click, go to Maven, and then update project. I'm going to update this project that I just created, Maven native, and then basically I also needed to save it, so we save the Maven project again and then update it. Update this one. And now, as you can see, it switches to Java 1.8 and the warning sign goes away. So whatever you change you make to the POM file, you have to save the project and then go to Maven and then update project, right? Alright, so this is our Maven. We have our traditional or conventional folder structure: source main Java, source main resources, source test Java, source test resources. So let's create a package here. Let's call this Maven native, and inside I'm going to create a new Java class. Let's call this test Maven JNI, for example. Doesn't really matter. Let's finish it. I want to have a main method, and in the main method I'm just going to have one method, test1, and in test1 it's going to be public static void test1, and I'm going to create a native method, public static native double multiply double x double y. So it's a very simple static native method that takes two doubles and multiplies them and then returns the result. So double result is multiply 1.1 and 2.2 and then sysout result. Alright, so this is the entire simple Java example. It's inside this Maven native. So what I need to do next, so right now the target folder is empty, there is nothing here. So what I need to do next is click on my Maven project, go to run and Maven build, and the goal here is going to compile and then maybe run. So it runs the Maven and build is successful. Now the target folder is created, and right now we don't see the classes folders, but if I go to properties and open the folder, inside this target folder there is a classes folder, and you see this is my package and this is my compiled basically class file. All right, so these classes is the root of our binaries or our class files. So all right, and now what I'm going to do next is, obviously I want to create a header file for this native and then have a dynamic library. So I'm going to go to the C++ perspective and then switch to the demo Maven. All right, this is my Java project, and then create a C++ project, Maven underscore native underscore C. Let's start with the hello world template, and then let's have both debug and release. That's fine. It creates the C++ project. We need to add it to our working set. So edit active working set, and then Maven native C. I'm going to add it to my working set. So this is my C++ project. Let's build it to make sure it works, and then let's run it. Okay, yes, it works. Everything looks fine. So I'm going to delete this because we don't want to create an executable. We want to create eventually a dynamic library. All right, so what I'm going to do first, I'm going to create a source folder, call it the header, inside the C++ project. This is my header file. Right now it's empty, and now this is the important part. I have to configure my external tool, Java Edge tool, to be able to create a header file and put it inside this header folder. So I'm going to go to my external configuration, and then Java Edge, I'm going to duplicate it. Let's call this Java Edge underscore Maven. All right, and then this is the important part. So the working directory for Maven project is the target/classes, and the classes folder is generated after you execute the compile goal on the compiler plugin, right? So I'm going to set this to workspace / project name / target / classes. All right, this is the working directory. Note that after the workspace we should always have this colon / right, because then it tells the Eclipse to append whatever comes after that to this workspace path. So after the workspace there's always a colon here. And then for the arguments, I want to create the header file and put it inside the header folder of my C++ project, which the name is Maven underscore native underscore C in the headers folder, and the Java type name. So this works fine. Let's apply this and close it. So the next is we select our Java file that has a native method and then run our Java H tool. So Java H underscore Maven. So everything looks fine. We get this header file, Maven underscore native underscore test Maven JNI, which is correct. So what I'm going to do next, I'm going to include the JNI header folders from the include folder of the C++ of the JDK. So we go to properties, C++ build. These are the routines, and then settings, C++ compiler, include, and then basically JDK contents, include, home, and then include. This adds the JNI.h, and then we also need the JNI.machine dependent for your platform. Mine is Darwin, which is macOS, JNI underscore MD. We also include these. And with this, all these errors should go away. And if I hit command and then click on JNI, I should be able to open it. That's okay. And then what I need to do next, let's delete this. What I need to do next is go to my properties of the C++ project, go to the build artifact, set it to shared library, and it automatically adds the dynamic lib as the extension, which is for macOS, and then lib to the beginning. And I always keep it like that. So okay. And then the last thing that I need to do, I need to create my CPP file. Let's empty it, and then all we need to do, we need to include our header file that we just generated, header, and then whatever was inside. There's only one header file, and then we copy and paste the prototype of the function, and we give it a implementation. So JNI environment, you can use JVM or env. I tend to prefer JVM because it's more clear what is doing. We're asking JVM to do stuff. J class is the calling class, test Maven JNI. That's because this is a static method, so we're getting a J class reference, not a J object reference. J double is X and J double is Y. And again, X and Y, J double on my computer maps directly to double. So what do we need to do? We need to return X times Y. All right. This multiplies them, and if in order to refresh your memory again, the signature of this native method is going to be Java underscore, which signifies we are binding to a Java method. Package name is let's look at the package name. Package name is this package, Maven Maven underscore native. So Maven underscore native. However, if you recall, we said that underscore in any Java file, Java name gets replaced by underscore one. That's why you see underscore one here. This underscore one signifies that there is an actual underscore in the name of the package in the Java. And then underscore class name, test Maven JNI underscore method name, multiply. All right. So package name, and then the class name, and then method name. And because there is no overloading happening here, there is no need for the signature of the parameters. This was just refresh your memory. So we created a header file successfully. We added an implementation, and all we have to do, and we set the C++ project to create a dynamic library. So all we have to do is build it. And then the binary is created. This is our dynamic library. Lib maven underscore native underscore c.dylib. And what we do, we copy this and paste it inside the resources folder, in the top level of the resources folder. You can paste it inside any folder. You can create a separate folder and put it there, but I tend to prefer just put it in the top level of the jar file, which means I directly copy it in this copy the dynamic library inside this resources folder. All right. So if I go back to my Java and then use, because I have a native method in this class, I have to load the dynamic library inside this class. So system dot load library, and the name of the library on macOS, we drop the lib from the beginning and drop the extension. So it's going to be maven underscore native underscore c. And so if I run this, hopefully this is going to give me the result. Let's see. no maven underscore native underscore c in the java.library.path. The question is why. So if I go back to the class, if I go back to open this and then go to the classes, it is inside the classes. So the question here is, why is it that it cannot load it? Okay, so the reason is that in Eclipse we said that when we have a run configuration, we either have to go to the VM arguments and give it -d java.library.path and set it to point to the folder that contains the dynamic library, or we can just right click, go to the basically properties here, and then go to Java build path, and in this source folder that we have maven native /source/ main /java, for all the Java files inside this basically source folder, I'm going to select a native library location and add the workspace, which is resources. All right. So what happens now, all the Java files that are inside this folder, src/main/java, there is a native library inside this src main resources that is associated with all of them. So if I run this should work. Yes, now we're getting the result 2.42 natively. So the next step is to be able to basically, so if I build this again, and then this time I'm going to go to run as maven build, and I'm going to, for the goal, I'm going to say package. So now my goal is to package it as a jar. So if I run this, Maven is going to go and create a snapshot package for me, building Maven native 001 snapshot, and the build was successful. Now if I go to my target folder, as you can see, the jar is there. So let's just open this target folder. And we said in the past that jar files are just zip files, so we can just unzip it from, okay. And if we look inside that, yes, the dynamic library is in fact at the root or the top level of the jar file, which is good, and we have our package and classes. The only thing is now is that if I give this jar to someone else and they run this class from within the jar file, this test maven JNI, they won't be able to, they will get an unsatisfied link error. That's because system.load library or system.load, both of them expect to find the native library inside some folder in the operating system, not inside the jar file. They cannot look inside the jar file. So what we need to do, we need to go to the GitHub and search for native -utils, and then this one, Adam Heinrich, and then this, let's just quickly download this. All right, and I'm just going to quickly basically unzip it, source file, and then in the main Java ch utils and this Java file, and we can just copy and paste it to our project. Paste. All right, and I just have to change the package name, and the rest. It's a very simple Java file. It just creates a temporary folder on your operating system based on the java.io.temp directory, and then it copies the dynamic library from inside the jar into that folder, and then calls the system.load. Right, instead of system.load library, it calls system.load and uses the absolute path to that dynamic library inside that temporary folder. All right, so it takes, basically it brings the dynamic library outside the jar. So what I do know, if I use basically native utils dot load from jar, and now I have to specify where the native util is within my jar file, and I'm going to tell it it's at the top of my jar file at the root, and then the name is the full name, lib maven underscore native underscore c dot dylib. And again, we have to specify the full name, including the lib and the extension, because it just appends this to the path to the temporary folder, and then it calls the system.load, and in the system.load we have to specify the absolute path, and it throws an exception. So if I run this should still work fine. Yes, because again, in the target the dynamic library has already been copied. Let's go back here. The dynamic library has already been copied to the root of the binary folder, which is the classes in this case, so that we can load it from the root of the binaries, which is the root of the jar file also, right? So what I need to do next, and again, let me just open this one more time. Right now, this native classes is also compiled, so everything looks good. But I need to execute basically the package again, so that this new class native utility is also included in my jar file. So let's select the Maven native and then run Maven build and then package and then run again. Build is successful, and then let's refresh this, and we have our zip jar file, and in the Maven utils we have both native utils.class and test Maven JNI. So both of them are here, and you see our dynamic library is also there. So everything looks good. How do I test if this is successful? I'm going to create a new Java project. So let's switch to the Java perspective, create a new Java project. Test Maven native. All right, let's finish this, and then here I'm just going to create a new folder. Let's call it lib, and maybe let's also close these. And then what I'm going to do, I'm going to copy and paste this jar that I created from Maven, and then add this to my build path. All right. Now I can go inside, and this test Maven JNI, I can run it, and as you can see, it still works fine, which means now this jar file has no problem loading this dynamic library. And the way it does that, again, the way we do it with native utils, is that it grabs this dynamic library and copies inside a temporary folder in our operating system, and then when we use any of these classes inside this jar file, it automatically loads this dynamic library from that temporary folder. And when JVM terminates, it deletes the temporary dynamic library, so it doesn't pollute your operating system. But this shows that when I execute this test Maven JNI from within this jar file, it shows that it is actually able to load this dynamic library. All right, so I hope you enjoyed this lecture. The main important point is with Maven is that the root of the binary directory, the bin, the working directory that you have to specify for Java Edge, is not the project name /bin. It's project name /target /classes, and this classes folder gets generated the first time you call the compile goal on the compiler plugin. I hope you enjoyed this lecture. Please stay tuned, and I'll see you in the next one.